Hello, everybody. My name is Wesley Zeng. I am a current rising sophomore studying computer science at Cornell University. And this past summer, I had a wonderful opportunity to work with Anodes on their autonomous intelligence project. And today, I'll be going over smart orchestration in agentic AI. So let's get started. So I want to start off with a brief introduction about what agentic AI is and what really separates it from other forms of AI. So, agentic AI refers to AI systems that can autonomously plan, act, and adapt to achieve goals. And what makes this particularly special is that it can leverage the power and reasoning capabilities that an LLM possesses to carry out and do complex tasks that a user can give it. It's able to independently operate, and it doesn't need constant human supervision at each step. It's able to plan its next steps, and it uses things known as tools to carry out its actions. Because on its own, an LLM has the power to reason, but it doesn't necessarily have the power to interact with the outside world, and that's where tools come into play. Additionally, memory and context, which can be passed messages between the user and the agent, or it can be the results from a tool call, are stored in an agent's memory. And from there, the agent is able to use it as context and use it to be able to make better decisions in the future. So let's talk about some of the key components in agentic AI. So with those being tools, resources, and prompts. Tools are external functions, APIs, and database queries, and they allow the LLM to interact with the outside world. For example, you might ask an agent how to, or you might ask the agent what the weather is like in Palo Alto, and the LLM on its own most likely doesn't know the answer to it off the top of its head. And the LLM will then reason and decide and look at which sorts of tools it has access to and then decide what tools it can call. So it'll call a weather API to look at what the weather is like in Palo Alto. Resources are static or dynamic sources of information, such as documents and files that add context to help the agents make informed decisions. So this can be, for example, a document that you give it or a database. These are resources or sources of information that the LLM doesn't necessarily have inherently. It wasn't information that it was trained on. It's context-specific information, such as perhaps a company's internal documentation, and they allow the AI agent to provide context-relevant results. Prompts are simply structured instructions in context that are given to the LLM. So this can come from the user itself, or it can be during intermediate reasoning steps where the LLM looks at the output from a tool and then it decides where to go from there. The LLM, it acts as the planner and decision maker, or the smart orchestrator. So it tries to interpret a user's query and takes into consideration any of the relevant context. And from there, it tries to plan what steps it should take next. And then it'll look at and select the right tools and resources to invoke based on its plan. And these tools and resources will then return an output. And the AI agent has to evaluate these outputs and decides whether or not to return or continue reasoning. So let's take a brief look at some of the applications of smart orchestration within agentic AI. So one of those could be smart cities and infrastructure. Another could be autonomous vehicles or AI assistance, robotics and logistics. And what makes agentic AI so useful in these particular applications is that they are very dynamic, right? So, for example, autonomous vehicles, right? Driving is something that requires a lot of a lot of different factors that can change in an instant, right? So, for example, the light It could be a red light or a green light at the traffic lights, or it could be the weather conditions, the positions of the car near you, or certain lanes are blocked off due to construction. The AI agent is able to take that into consideration and from there plan what it's going to do next. It's not locked into any specific workflow or set of instructions where it has to do one thing at a time. It's able to take in its surroundings and then change its plans based on what it receives from its surroundings. So let's get into our product overview on what we've developed so far. Currently, what we have is a reactive agent. React, which stands for reasoning and act, not to be confused with the popular front-end JavaScript library, is a prompt engineering pattern where the agent alternates between reasoning steps and action steps. Reasoning steps are where the LLM is thinking and deciding on what to do next, and the action steps are where the LLM decides to actually carry out the plans that it makes during the internal thinking step. So here's an example workflow where a user asks the agent what the population of France is. The AI agent in this scenario has been given access to a tool to get general information. So, what of a thought? It'll say, I don't know what the current population of France is. Maybe I should search for it, right? So it'll search for the current population of France through a tool. And this general information tool will return and say that the result is roughly 67 million people. And from there, the agent can decide whether to continue to call other tools, or it'll decide in this scenario that the answer is satisfactory, and it'll give the user the final output that the population is about 67 million people. So I prepared a little video demonstration and to show us how the agent works live. So first, I decided to greet the agent, hello, and from there, it'll respond back. It'll say, hello, how can I assist you today? I ask it a random trivia question about the Treaty of Paris. There are multiple treaties of Paris, and the agent accesses its tool, right? And it'll give me a brief summary of all the relevant treaties at Paris. From there, I decided to upload a document, a PDF of my resume, and I asked it some specific questions about my resume that it would only know through retrieving information from that document that I gave it. So I asked it, could you tell me where Wesley Zeng currently goes to school? And it'll tell me that I currently go to school at Cornell University. So that's kind of how the agent works. You can ask it general information, or you can also upload documents and the agent will be able to get the relevant information from the documents instead. And there are a couple of specific points within the demonstration that I do want to go a bit further in. Firstly, it's on how LLMs are trained on a vast number of sources that contain a lot of general information. So the LLM has access to a tool that can query general information. And the LLM has access to it because the LLM was most likely trained on sources such as Wikipedia or history.com and a lot of different science journals. So it knows a lot about very large topics. Because, for example, I asked it when the sport of basketball was invented. This is a pretty general fact, somewhat well known, and most likely already has a lot of sources and documents detailing it on the internet. And so the LLM knows about it, and it'll tell me that basketball was invented in December of 1891 by Dr. James Naismith. On the other hand, when I ask it where I go to school, it'll decide, well, first it'll try to look for any relevant documents, right? It invokes the document retrieval tool. And because it doesn't necessarily know who I am, it'll try to look for any relevant information of my resume. And then it'll see that, oh, well, Wesley Zeng goes to Cornell University and he's currently studying computer science with a minor in math. Another very nice or neat feature of our AI agent is that I can access the chat's history. So I ask it, when does he graduate? In a simpler AI model, this LLM would most likely fail because it doesn't know who he is referring to. Every single time I ask the chatbot a question and it gives me a response, it exists in its own separate vacuum. But in this scenario, it doesn't. The LLM first tries to gather any sort of context and look into the previous chat history to see what could he in this scenario refer to. So it'll access the chat history and it'll see that he in this scenario actually refers to me, Wesley Zeng. And then from there it'll see that, oh, the user is asking when does Wesley Zeng graduate? And then it'll access the document retrieval tool and it'll tell me that Wesley Zeng is expected to graduate from Cornell in May 2028. So that's what we have so far. But we also have a lot planned on what we can do to further this agentic AI system. Firstly, one of our next steps is to incorporate a multi-agent system where instead of having one specific agent that is able to delegate its subtasks to tools and resources, it can actually invoke, a single agent can actually invoke other agents. And these agents can have access to other agents or their own tools or resources. And this is particularly powerful in a lot of different situations. For example, a lot of these agents can now run in parallel or asynchronously. So if a user asks the agent to write emails to some startup founders in the NYC area, it doesn't necessarily need to do it one at a time, right? It can have multiple different agents doing this at the same time. It also allows for separation of concerns. So in another scenario, you might want to have a specific agent that does web scraping or another one that specifically focuses on deep research. And in this scenario, you can really allow a lot of software developers to scale specific agents. If they want to scale a specific feature or if there are errors, you might want to be able to see I want to focus on where exactly a system is currently not working as intended, and you can debug that specific agent by looking into the tools that only this specific agent might have access to. Another thing that we're looking to do is incorporating the AI agent with Model Context Protocol, aka MCP. And this will allow for it to call tools and resources that are not hosted locally, but they're actually hosted on a server. MCP is a generalized model agnostic protocol that was recently developed by Anthropic. And what it allows for is it's a standard protocol that allows agents to be able to interact with one specific server. And this is particularly good for scalability. When you want to scale a large system of agents, when multiple agents are connected to one server, they can all share resources and tools. If without MCP, it would be a lot more difficult because for every single AI agent, you would need one specific document or one specific tool on each agent's local system. But now all these agents can call one single hosted resource on a server. And this is also really good because if you want to change one specific tool, you don't have to change it for every agent. You can just simply change it on the server. And this will be changed for all the different agents as well. And finally, we're thinking about also developing user-controlled autonomy settings that let users control how much autonomy an agent has over its actions. So an agent has a lot of capabilities, but LLMs can also make mistakes. They are not perfect. And in certain scenarios where there is a high amount of risk, it might actually be necessary to incorporate some human supervision. And for example, when an agent gets up to a certain point, it might want a human to look over what it's done and make sure that it's on the right track before it allows the agent to continue. So I want to share an example of how a multi-agent workflow could really look like, right? So we can have a smart orchestrator, and this is one specific agent that's specifically dedicated to calling other agents. And let's just say that a user wants to plan a trip to NYC. It's able to call an agent that specifically looks at the user's budget. It'll have an agent specifically for booking the hotel and finding the right flights and checking the availability. So looking at when the user might have certain meetings or when the user has to get back. And from there, the smart orchestrator can take into consideration all the results of these different agents that have access to their own specific tools. And when it believes that it has achieved a satisfactory answer to the user's query, it'll be able to it'll call a notification agent. And this notification notification agent will finally be able to give an output to the user with a planned vacation or a planned trip to NYC with a budgeted breakdown of how much it's going to cost and the dates that are going to be very important. And with that, thank you so much for listening. I really appreciate the time, and it really means a lot to me that you were able to listen to my presentation. Thank you.